Hi everyone, so 6.4 deals with nth roots. Now we have taken square roots and we've even taken cubed roots at this point, but we are going to mix it up a little bit more and do some more work with these. So I'm going to be referring to the index, which if it's a regular square, it's just a 2. We don't have to, it's understood if it's the square root of 81, the index is 2. When it's anything higher, it will be listed. So for example, we saw the cubed root of 64 occasionally, the index was 3. Number on the inside, still called the radicand. So there's a couple different situations that could happen, depending on whether your index is even or if it's odd. Let's take a look at if our index is even. If our index is even and our radicand is less than 0, for example, the square root of negative 3, we know that there are no real solutions for that. Nothing's going to give us that. The only thing that might give us that is imaginary numbers, but we want to deal with the real. If our index is even and our radicand is 0, the square root of 0 is simply 0. So that's one real solution. And it's neither positive nor negative, it's just 0. If our radicand is greater than 0, for example, the square root of 4 is 2, or really it could also be negative 2, we can have one positive and one negative. The positive one is called our principal root, and we'll talk about that more in a second. If our index is odd, say the cubed root of negative 8, well, I can do negative 2 times negative 2 times negative 2, and that will give me negative 8. So I can get an answer. I have one real solution, and it's negative. Alright, say our radicand was 0. Cube root of 0, just like the square root, it's still 0, so I have one real solution. And again, it's neither positive nor negative, it's just 0. Cubed root of a positive number, a number greater than 0. Well, 2 times 2 times 2 does give me 8. Negative 2 times negative 2 times negative 2 would not give me 8. That would give me that negative 8 like we had above. So that would give me an answer of 2. So it's one real, and that's a positive solution. Now, as I mentioned, our positive root is called our principal root. Occasionally, they might say, hey, give me the negative square root of 49, or maybe give me the positive negative square root of 64. If they want something other than your principal root, they'll tell you. They'll make it clear. For example, I want the negative square root of 324. Well, the square root of 324 is 18. And I want the negative 1, so I'm just going to tack on a negative, and that's my answer. I want the cubed root of negative 64. I can take the cubed root of negatives. It's going to be negative 4. I want the positive and negative square root of 81, so that's going to be positive and negative 9. And I want the sixth root of 64. In case you don't know that that's 2 offhand, if you look at your calculator and you turn it on, we have seen in the math menu that there's that cubed root function. However, if I want something other than a cube, for example, I want a 6 here, I type in my 6, whatever I want my index to be. I hit math, scroll down to option 5, and then type in whichever number I wish to take the, in this case, 6th root of, and it'll give me my answer. And again, since there's no positive or negative out in front, it's presumed that we want the principal root. Here we have the negatives, the square root of negative parentheses 14a squared. I've got a square root, and there's negative inside, and the negative is not inside the parentheses to be squared. I cannot take the square root of a negative number, so there's no solution for that one. Now here's where we start to talk about an interesting case. if your index is even, your power on the inside is even, and your power on the outside, once you have taken the whatever root, is odd, you do need to add absolute value bars. So let's take a look at this one, for example. I do have an even index. I have an index of 2, it's understood. I have 2 who have even powers on the inside. Square root of 49 is just 7, that doesn't cause me any issue. Square root of m squared is m. Square root of t to the 8th is t to the 4th. If you want to think, alright, what power to the squared would get me that 8, it's going to be that 4, if you want to reverse engineer it. Now, one of these has an odd power outside, and that's the m. To ensure that I have the principal root of m, I need to put absolute value bars around it. It needs to be part of your answer. You don't need it for the whole thing, just whatever variable or whatever binomial needs it. Whatever has, if these two situations exist and your power that's on the outside ends up being odd, like it was just for our m, we do need to put absolute value bars around our answer from the outside. And let's take a look at 2 more. So sometimes you might have a binomial to a certain power. But we do have an odd even index, even power on the inside. Let's see what we get on the outside. So if I'm thinking which binomial to the 4th power would then get me 8, I'm looking at x minus 5 squared. I don't have to separate these. I don't have to FOIL it out. I just have to think, alright, well, what power to the 4th is going to give me an 8, or something that we'll see later on in this chapter. If you have for example, a square root, that's an exponent of 1/2. So it would follow that a 4th root would be an exponent of 1/4, if that helps you. So if you're just dividing that 8 by 4. In this case, our power on the outside is not odd, so I do not have to worry about any absolute value bars. This is already going to be a positive answer for me. Now this last one, it's going to be very tempting just to take the square root of each piece. You cannot. This actually turns into one that's very similar to the one on the left. This, we do our favorite, we factor. If it's factorable, which it should be. So I've got x plus 5, x plus 5, aka x plus 5 squared, even index, even power on the inside. Square root of x plus 5 squared is x plus 5, because that is to the 1st power. I put my absolute value bars, and then it's done.